All right, so today we're starting off the unit with graphing quadratics with transformations. So if you remember back to a few units ago, we talked a little bit about quadratics and how they make parabolas. And so we end up having this parent function graph, and remember that they are symmetrical. And so now we're taking those parent graphs and we're applying transformations to them. So it's the same as it was before. If it's inside parentheses, you do the opposite, and it's left and right. And if it's outside, you do whatever it says, and you go up or down. So this -4 means we're going down 4. So I'm going to go down 4 for each of these points. And our quadratic is going to hold the exact same shape. It is not going to change. It's going to look exactly the same. I just pushed it down 4, and then I can connect my dots, make sure you draw arrows. And then it also asks us to find the x-intercepts, the maximum, minimum value, and the domain and the range. So first, if we're going to find the x-intercepts, I can find those by taking this equation and factoring them, because your x-intercepts are when the function is equal to 0. And so if we factor this, x plus or minus 2, since it's a difference of 2 squares, I get that my x-intercepts are at 2 and -2, and those are points, so we need to make sure we write them as points. Okay, and then boom, there they are. Then it says to do domain and range. So domain, remember, is your x's, and so this is going to be everything. And then the range is going to be your y values, and the lowest point that we hit is at -4 with the bracket all the way up to infinity. Okay, something that's a little bit new is it even asks for the minimum or the maximum. Well, this one, it has a minimum because at its lowest point, we have a specific value. You might be thinking, well, the maximum point's infinity, but that's not a point. So we're going to say the minimum, if I can write, minimum is, the minimum value is, in this case, -4. Okay, so we have our domain and range, we have our minimum value, we have our x-intercepts, and these would be our x-intercepts right there. Okay, so there's number 1. I know I'm going pretty quick, but for the most part, that is review. Number 2, kind of the same things going on. Again, you have your parent function, and then you need to figure out which transformations are happening from that. You do not have to graph the parent function every single time. I'm just doing it to show you. So again, that's just x squared. And so over here in our equation, we have x -3, which means we're going to go to the right 3. And then I have -7, which means we're going to go down 3. So since those are addition and subtraction, we can do whichever ones we want to first. It's not going to impact what happens. So I'm going to go 1, 2, 3 to the right, and then down 7. And so then there's our vertex point. And then again, the behavior of the parabola is going to be exactly the same. I am just pushing it to the right 3 and down 7. Down 7. Whoops, I wrote that wrong. Down 7. Okay. And so your new points, again, are going to be in the exact same spot. Or I'm sorry, they're going to be in the exact same behavior. They're going to look the exact same. We're just pushing them, pushing the whole thing to the right and then down. And so you get that graph right there. So for our x-intercepts, again, we can just set it equal to 0. So this is going to be x -3 squared equals, add 7 to both sides, we get 7, square root, x -3 equals, and then when you square root something, it's plus or minus. So this is plus or minus 7. And so we get x equals 3 plus or minus 7. Those aren't really like actual value. Well, I mean, they are actual values, but it's kind of hard for us to see what those represent right now. And so where those technically are, if you do 3 plus the square root of 7, is that it's at 5.65 comma 0. And if I do 3 minus the square root of 7, the other point would then be at 0.35, comma 0. So there's your x-intercepts, okay? I'll let you know in class whether or not we're going to be using a calculator for this, but at the moment, I'm just telling you. Then we need to find our minimum or maximum. So again, this one hits the bottom of the parabola, so that's going to be a minimum value, and it's going to be at its lowest point, which in this case would be -7. Then you have your domain and your range. Nothing's changed there, -infinity to infinity. The range, the lowest point, again, we are hitting it at -7 all the way up to infinity. And then we have all of our points, okay? So a lot of that is review. I know I'm going really quick, but a lot of that is just kind of graphing it and see what happens. So for the standard form for quadratics, we get this as an example. Well, this is not as easily graphed on a graph because it's hard to tell what the transformations are. It's really tough to look at this and say, oh, I'm going up or down this much, or oh, I'm doing this or doing that, or I'm reflecting and that kind of stuff. It's a little bit harder to see. So what we can do is we can complete a table for the values by just plugging them in. So like for this first one, if I have negative, and I can substitute in -3 minus 2 times -3 plus 8, I can get the y value that's going to be outputted for that. And so let's see, -3 squared would be 9 times a negative is -9. That's plus 6 plus 8. So that's 14 minus 9 would be 5. Then we can do it again with -2 and think, okay, negative times -2 squared minus 2 times -2 plus 8. So that's 4, -4 plus 4 plus 8 would then be 8. And if we kept doing that, just for the time's sake, if we kept doing that, we would find that these are our values, okay? And so that could be graphed for us on the graph. It's not going to be the entire thing, and it's going to give us some really helpful information, but I don't know where our x and y intercepts are because they're not given to us on the table. We do know the y-intercept, which is going to be at 0,8. We do have that one. But I don't know what the x-intercept is. So, same as the problems before, to find the x-intercept, we're going to have to take the equation, -x squared minus 2x plus 8, and set it equal to 0, because when x crosses, or when the graph crosses the x-axis, that's when y is equal to 0. And then we just need to factor. So the first thing I would do on factoring for this is I would notice that I can take out a negative GCF, and we get this right here, and then that's factorable to x plus 4 and x minus 2. So x is -4 and +2. So we need to put those in points. -4, comma 0, and 2, comma 0 are going to be our x-intercepts. Okay. Then we need to determine the vertex and the axis of symmetry for the parabola. Well, if I go graph all those other points that we found originally, so this would be -3, 5, and -2, 8, and I'm just now realizing that I graphed, no I didn't, okay, sorry, -1, 9, and then it starts coming down the other side. I have 1, comma 5, so notice it is symmetrical. And so I can kind of curve out my parabola right here, but if I just draw that much, it's hard for me to tell exactly where the x-intercepts are. Well, now we found them, so that's good. And then I need to determine the vertex and the axis of symmetry. Well, the vertex is the turning point, so that's this point way up here. So the vertex is nice. It gives it to us at -1, comma 9. And then the axis of symmetry is where you would fold it in half. And for parabolas, at least for right now, 9 times out of 10, it's going to be x equals, and it's whatever vertical line I would use to cut this in half. So it's going to be actually the x value of the parabola. So the x value, or I'm sorry, of the vertex. So x equals -1 for our axis of symmetry. Okay, so there's all those pieces. So the reason we do not like it in this format is it kind of requires all this extra work for us to do. On the next page, there are going to be ways for us to use that information to determine specific things about our graph. So we have, when we're determining the direction, if our A value is less than 0, then the parabola is going to be opening down. And if A is greater than 0, then the parabola is going to be opening up. So that A value is the coefficient out in front. So if it's negative x squared, it's going to be going down. If it's just positive x squared, it's going to be going up. Then we have for the vertex, the x-coordinate of the vertex is equal to this equation. And this is going to be an important equation for you to memorize. It's going to be h equals negative b over 2a. Negative b over 2a. And this is also important because it's going to tell us exactly where the axis of symmetry is. Okay. To find the y-coordinate, we're going to substitute the x-coordinate of the vertex. Substitute the x-coordinate of the vertex into the equation. Into the equation. Okay. The vertex is also always going to be written as a point. So we're going to need to put it in parentheses. And the axis of symmetry will always be x equals something. You're always going to write as a line, always x equals something. Okay. Then to find the y-intercept, you're always going to just substitute in 0 for x. So that's going to tell us exactly what the y value is when it is 0. And then we know that the symmetric point is the reflection over the line of symmetry. Okay, so I know that was kind of a lot, but we're getting pretty close to being able to put it into practice, and we're able to say a lot of really important characteristics about our parabola just based off of looking at certain things of the equation. So the domain of the quadratic is always negative infinity to infinity. We kind of saw that on the first two. They were both negative infinity to infinity. And the range is either going to be the minimum, comma, to negative infinity, or positive infinity, when it opens up, or it's going to be negative infinity to the maximum, because that's going to be the highest point that it reaches at, the maximum. So we're going to be able to use all of that to graph without a calculator. And so we've got two problems to try it out and see what happens. And here we go. So it says y equals 2x squared minus 8x plus 6. Find the direction, the axis of symmetry, vertex, y-intercept, and the symmetrical point, and the domain and range. So it has all that labeled for you, but we need to put kind of all those pieces together so that we can go and graph, okay? So the first thing to notice would be the A value is bigger than 1, so this is going to be opening up. It's going to be opening up. It's going to look like a U. And then we can go and find the axis of symmetry. Well, the axis of symmetry can be found by that equation, negative b over 2a. And so just like with your quadratic formula, we're going to say that negative b would be negative times negative 8 all over 2 times 2 from the coefficient in front. So negative times negative is positive over 4, so that would be 2. So the axis of symmetry is at x equals 2. Again, the benefit of doing that is now I already know what the x-coordinate of the vertex is. Those numbers are always going to be the same. Every single time they're going to be the same. So now we need to go and calculate the y value for the vertex, and the way to do that is just by plugging it in. So we're going to plug in 2 into this equation. So it'd kind of be like f of 2 equals 2 times 2 squared minus 8 times 2 plus 6. So 2 times 2 is 4, times 2 would be 8. 8 times, or negative 8 times 2 is negative 16 plus 6. Combine those, and we're going to get that as -2 for our vertex. Okay? If you would like to graph things as you find them, that's totally fine. Sometimes I do them all at the same time at the end, or I do it as I find it. It just kind of depends, but it does not matter, whatever works for you. The y-intercept is going to be when you set x equal to 0. So now we need to say that f of 0 is equal to 2 times 0 squared minus 8 times 0 plus 6. And what you'll notice is the more and more and more you do this is that that's always going to be 0, that's always going to be 0, and it's always going to result in whatever that constant is at the end. And so we get that the y-intercept is at 0, positive 6, 0, positive 6. So I'm just going to go ahead and graph what we have so far just to show you. So we have 0, 6, and I have 2, -2, and I know that my graph is going to be opening up, and I know that there's going to be an axis of symmetry on x equals 2, which is the x value of my vertex. So if I was going to calculate and figure out where the symmetrical point is, remember, all parabolas are symmetric. You can fold them in half and it's going to line up perfectly. So if I have a distance of 2 here, if I have a distance of 2 right there, then I must also have a distance of 2 there. So this is the perfect symmetrical point on the other side. And then we can fill in the rest of our parabola, kind of going up through that point, and we're going to keep on going. And so we end up drawing it. We'll have to hit 4, 6, and we get a decently pretty good picture for our parabola, decently precise. So the last thing to do would be to do the domain and the range. Domain is always -infinity to infinity. And then the range would be the minimum, which is at -2. -2, infinity, and we are done. Okay? And we are done. So, last one, number 5. We're going to try to go through it probably about the same pace. First thing to notice is that a value in front is negative, which means the parabola is going to be opens down for this one. The axis of symmetry, again, can be found by using the -b over 2a. So negative b, that'd be -2 over 2 times -1/2. So you got to be really careful with your signs. So we have negative times negative is positive, and then 2 times -1/2 is -1, so -4. Or did I do that wrong? Wait, hold on. Negative, that's -4. Oh, why did I put 4 on top? Yeah, okay. That's wrong. I'm sorry. Go back. So, negative times negative would be just +2. I don't know why I put 4. And then half of 2 would be -1, so it's at 2. There we go. That's better. Okay. So, the vertex is at x equals +2. And so, if you want to go ahead and write out your axis of symmetry and draw it, you totally could. And put that dotted line that goes all the way up top and bottom. Since the vertex is always going to be on the axis of symmetry, we can go ahead and fill in +2. We can go in and fill in +2. Then I need to plug in 2 to the equation to figure out the y value of where that is. So this would be f of 2 equals -1/2 of 2 squared minus 2 times 2 plus 3. PEMDAS rules, 2 times 2 would be 4. Half of +4 would be 2 with the negative, so -2. That's -4 plus 3. So that should be I need to plug in I'm losing my mind. Hold on, we're losing it. I'm doing all this wrong. Hold on, go back. I'm sorry. All right, I'm going too fast. There's the lesson. This needs to be a negative. Boom. If that's a negative, then that's a negative. Then we have f of negative 2 equals negative 1/2 of negative 2 squared minus 2 times negative 2 plus 3. That's going to end up working better. So negative 2 squared, positive 4, half of positive 4 is negative 2. Negative 2 times negative 2 is positive 4. So that's plus 4 plus 3, and you get 5. So that's 5 for the vertex. So if I went ahead and put it, I need to change my drawing for the axis of symmetry. It's going to go right there. Then we have negative 2, positive 5, and I know it's going to be opening down, so I can predict where my y-intercept is going to be based off of that. So if I plug in 0, f of 0 is negative 1/2 0 squared minus 2 times 0 plus 3. Well, that's 0 and that's 0, so it's going to be 3. 0, 3. And then this is when the symmetrical part. So since all parabolas, again, are symmetric, then that means if this has a distance of 2, that means this has to have a distance of 2. So I find that there's a new point at negative 4, 3. And that would be our symmetrical point. Negative 4, 3. Then we can kind of draw out our parabola. It's going to look something a little bit like that. We can find our domain and range. Domain is always negative infinity to infinity. And then the range now would be the maximum at 5. But we have the lowest point being negative infinity all the way up to 5 with a bracket. And so then that's all the information that we need to know. So I know I went through it really quick, but here are the highlights. You really need to know this formula right there, negative b over 2a. It's going to show up when you try to find your axis of symmetry and when you find your vertex. Everything else is just going to be remembering kind of, okay, if the y-intercept, that means x is equal to 0. That means x is equal to 0. The vertex, you're going to have to go plug in for and solve once you have the axis of symmetry. And then domain and range has not changed from before. You're just going to have to remember how to do them. All right. So if you have any questions, let me know. Other than that, we are done.